Okay, I've never really done this before, but I'm going to try to walk us through the process that I went through to recreate in SolidWorks the mechanical drawings that Pop made for his Virginia 2 steam train. These are the original drawings that I have, and then I'm going to show these over here, which are just the same drawing but cropped and color corrected, so you can see the lines easier. These are the drawings that I worked to, and this is the same lighting. This has just been white balance corrected. So in this case, we've got the first sheet of his drawing showing the aft main frame. Got a cross member here, this cross member here. This is a side view. Here's the bottom view of the same part. Some blocks controlling the lateral movement of the axle blocks. And here's an axle block here. And then we use this later to get to the arrangement of the wheels, the side rods, the main rods, and the eccentrics that make the part move. I might be a little over detailed for some of this, for some of you, but then a little under detailed for others. I'm going to share this video with several people, so just bear with me. And this is my great-grandfather, Gerald Horban, Steve's great-grandfather. And he built this live steam train, and I ended up with the drawings for him. And I ended up with about 30 sheets, maybe a little more than that. But it turns out it's 3 separate trains. He built the Virginia, which I remember the story that it was just too small for him. He said it was too small, so he started again with a larger one, which I assume is this one, Virginia 2. And then he ended up building one called Steamin' Demon, I guess, or at least the drawings for it. But I don't know that he ever built that one. I'm going to just go through Virginia 2, and then the next step after I model it all in SolidWorks as close to his original drawings as possible is going to be to remodel the train to 3D print it and try to make a working model. With that one, I'm going to take a lot of liberties. So in this case, we've got a member here, we've got 2 members here, and a bottom member at the bottom. So 1, 2, 3, 4, 5, 6 different parts, and I'm going to fuse those all together in my version, well, including these cross braces. I'm going to make it all one so that I can just print it all as one piece. It'll be a lot stronger because I don't have a way to weld these joints. In this case, he used a screw, but on some of the parts later on, he silver soldered and welded parts together, and I don't have a way to do that with plastic, so I'm just going to print them as one piece. Additionally, there's stuff like this wheel where the main rod has a bushing on one side, and the side rod has a bushing. Actually, the main rod has them on both sides. If I have that bushing on there, it's only about a 32nd of an inch thick. If I have that bushing on there, the rod won't fit flat on the printer, meaning I won't be able to get a print of it. So I'm just going to take those bushings off and then print a spacer or a washer to take the slack back up. So this is sheet 1 of the main frame. And when you take those parts and model it all in SolidWorks, you get this part here. So again, we can see the parts, and these bearing blocks move up and down. The axles will go through there, and the wheels will go through. The foreframe will connect to here. Then for sheet 2, showing the foreframe, the location of the Steve cylinder. This is important later. I need this dimension later. The pilot or cow crutcher on the front, the flag poles, the front platform that goes right here, the cross head guide. He's got it X'd out, so I ended up creating because it ultimately didn't fit. We'll see a lot of dimensions where he's just entirely X'd out entire assemblies or dimensions and made changes. I assume after he physically made the machine, he said, that didn't work, and he redid it. And sometimes he went back and made updates to the drawings. sometimes I don't think he did. So sheet 2, when you model sheet 2 as an assembly, we get the foreframe, which is simply a matter of this. In this case, he's got an opening in the back of the pilot. He's got 4 sides, which I don't really like it as a 3D printing step. I've wanted the rigidity, so I created it solid, which worked out a little better actually, because then I could put these holes in it for the cross braces that he's got. Moving on to sheet 2A, again showing the steam cylinder. This is showing the locations of the valve gear assemblies that we'll need later, just the dimensions. There's no assembly for that. Here's the drive wheels, the axle and the drive wheels. It's an interesting profile for the drive wheels. So if we turn it sideways, we get this shape here. This was a lot of fun to model, because normally you just kind of make these big square pieces, and this one, when it actually printed out, was kind of cool. The axles, and then we get 2 pins, a main pin and a side pin, which the side pin is connecting the side arms, and the main pin's connecting the main rods. Sheet 3 is just the wheels. So, and turn the wheels on the axles, and then those pins will go here, and then there's a key that'll lock the wheel to the axle on the left and right side. Here's sheet 4. These are the bearings and spring supports for the drive wheels. We've got a equalizer here, which externally is a block. Internally, there's this V channel, and this V channel rides right here. So this part goes up and down. That's this part here, putting different tension on left or right side of the leaf springs, which keeps the drive wheel, that axle would be right here. This is that axle block that goes up and down. So the drive wheel would be right here. So it'll keep the pressure on these spring holders. And then it'll equalize the tension front and aft by pivoting on this equalizer bar. This is the axle box again that I modeled in that other drawing. And when we put sheet 4 together, first thing I did was I created some leaf springs. I just modeled what he made here, 4 inches on center with the 1/8 inch depth, and then I just kind of created some. I think this is 2/200ths of an inch thick, and then just dot, because I don't particularly care about bearing the load. I just want something that'll kind of bear the load, because it's all going to be in plastic. And if I need to make it thicker or thinner in the actual 3D model, I will. But when you put all these springs and links together, this is the assembly there. The frame, lower frame goes here. These connect to the axle blocks as above. And here's the pivot. Well, I'm not going to be able to, so it'll pivot like that. Sheet 5 is the front truck details. Again, we got some springs, which are going to go here. Frame, the cross members, the top members, and the bearing support. So here's the frame. The cross member is here, going in the drawing front to back. And the bottom one, this is another spring guide here, which is a hole in the middle for the leaf springs. I like this drawing because it's a little curly detail here. On the other one, he just had straight blocks, but I kind of like this curly detail here, given this shape in this location. I did it on both ends, obviously. And I also, in this case, I took a little liberty here. He's got kind of straight profiles on the wheel. But about this time, I noticed that there is a set of mechanical drawings released in a magazine for Popular Model Engineering, I think was the name of it, in 1958, over several months, and it was for the Virginia steam engine. And at first, I thought these were just copies of that. It turns out they're whole cloth remakes. He obviously started with that and then just made a lot of changes to make it his own, to make it easier to machine at home, this, that, and the other. So in the original Virginia, this is kind of an S curve, which is just a much nicer looking wheel. I thought it was much cooler, so I took some liberty with that. He's got a redrawn profile actually here, where it's a double-sided spoke. So this is going to be a round spoke, as opposed to just the flat back. I can never print that, so I stayed with this example. I just kind of incorporated that in the new one and made kind of this S curve. And when you put that all together, we get sheet 5, which is the front trucks. So here you can see, I kind of like the curve of that a little better. It pivots up and down like that. For sheet 7, 6, this is a top view of the same truck. There's the truck, but this is detailing the swivel that it mounts to. This bolster attaches to the mainframe, and then this part hangs down on some pivots, swing links. So this will swing back and forth so that the locomotive can kind of rock to absorb the shock of any rail transitions and things like that. So this will swing back and forth, as well as pivot around this point here. So if this is the center, it'll turn this way or this way, and then this whole platform moves starboard and port. So when we model that all together, we get the truck swivel. Here we go. So the bolster stays fixed to the frame, and then let's see if I can demonstrate this. So this will swing back and forth like that. Sheet 7, this sheet gave me a really hard time because I wasn't familiar with the steam cylinders. Here we have an end view, a top view, and then a right view. This is a cap that goes over the end of this on one end. This is a cap that goes on the other end. This one has a hole in it for the arm to come in and out for the piston. So here's the piston. So this rod goes through this hole here into this part of the piston will fill the cylinder here, and then it runs back and forth left to right this way. There's an inlet and exhaust ports. Here's the detail for the piston hole. There's an exhaust tube here, and there's an inlet tube that's on the other side top. Actually, here's the exhaust, here's the inlet. So the steam comes in here, down into the cylinder on one side or the other of the piston, pushing it back and forth. And at the same time, on top is the slide valve. Now, the slide valve is what gave me a lot of trouble because I can see the isometric view here, but I didn't understand how it all fit together. It took me a long time to figure this out. And this is just a rod and a connector that goes on the end that pushes this plate back and forth inside this box on top of this, and which allows the steam to go left side, right side, over and over and over again. There's a port on the starboard side because this is the main frame, and if you just tried to use one, then the pistons would be on the wrong side, right? So there's a port on the starboard side, and it works out to an assembly like this. So if we hollow this, we can see the piston inside, and it just end to end to end. And on the top, we've got the slide valve going left to right, back and forth. So looking down on this, when the piston's at this end, the steam comes in the vent, in the port, fills the cavity, goes down this vent here, increasing the steam on this side, forcing the piston to go this way. As the wheels turn and the valve gears push this back the other way, now the steam's constantly coming in the port at a pressure. Now the slide's back on the other side, so now the steam goes down this opening, forcing the piston back this way. And the steam just alternates left side, right side, pushing this back and forth. At the same time, let's see if there's a cavity here with some ports, and they align with the exhaust to, as this goes back and forth, I think my explanation's a little off, but the piston pushing this way, when the steam's filling this side, pushing the piston gases out, and they go in the main channel and then out the exhaust. This is forcing it up through that cavity, through the tubes, and then out. And it took me forever to just figure out what all was going on this sheet, but I think I've got it sorted out in the end. Here's those ports. So when the piston got to that side, it's pushing the steam up through that little cavity, out to the thing. Now that I'm talking about it, I'm not quite sure that I've done this right, but whatever. I'll figure it out in a minute. And then the starboard side is just the same system, except mirrored. Sheet 8 is the valve gear linkage. It's another one that I had all the parts modeled, no problem. And then it was just a matter of figuring out which pieces went to which pieces to get this arrangement. The rods and the gear and here, there, and the other. And, does this hole connect to that hole? Does that hole, which end does that connect to? How does this connect to here? Da, 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 da. It took me quite a few days, but the reversing lever here was pretty straightforward. In this case, we've got a pin that, as the arm can engage or disengage there, to lock it in place. And then this just rolls forward and back. This will be in the cockpit, and then there's a linkage that runs off to the rest of the valve gear. And then the valve gear assembly looks like this. So the drive wheels would be here, going around. I don't know if this is mated properly. So as this rotates around, you can see it's moving. I thought I had a drawing with it all assembled together. Yeah. Okay, so here. We'll just ignore the errors for the moment, but you can see how it's connected together. So now as this wheel rotates, it's not going to, as this rotates, it moves this arm back and forth, which changes this bell crank in and out, which changes this to pull this in and out, which makes the steam valve go back and forth, which changes the piston, which changes the crosshead, which actually turns the wheel. So it's all linked back to itself. So, you know, the steam cylinder turns the wheel feeds back and turns the slide valve. Then this assembly here slides forward and back, which connects to the reversing gear. But by changing this forward and back just slightly, it changes the relationship. This is not connected to this. There's a link in between. It changes the relationship on this bell crank and alters the distance that the slide valve will travel. So if you've got it in full power, the slide valve moves from its extreme to allow the maximum amount of steam into the cylinder at any given time, which is full power. But then once the locomotive is moving, you don't need as much power just to keep it rolling. You just need to maintain it. So you can adjust it forward a little bit, which will let less steam into the steam valve or into the piston, but the inertia of the wheels already keeping it moving, so you don't need as much to just maintain for losses. And it's much more efficient on the boiler. You don't lose as much steam just wasted into the atmosphere for no reason. Additionally, you can pull it further back, alter this to the point that it reverses the order relative to these two, and it puts steam on the other side then in forward, so it reverses the steam engine. It's pretty cool. But it's another part that the sheet took me as long as the cylinders just to figure out. And now that I'm looking at it, I'm still not positive if I have the cylinders correct. Sheet 9 shows the smoke box detail. So the steam in the boiler comes out here, gets diverted into the superheater, goes back to the back. It'll be easier to see on a different view. Goes back to the back of the boiler, comes back to the front of the boiler, down the tube, into the steam valve on each side. The piston goes to an exhaust. This bigger tube comes up into the smoke box. So here's the exhaust coming up into the smoke box. The front of the smoke box here. There's not really any assembly here. That's the best part view that I had for these connections, and there's no details for these fittings, so I ended up just kind of making all these parts. When we look at the final assembly, you'll see some parts in red. Those are parts that I just kind of made up because there's not really any details to manufacture them. Sheet 10 is the main rods and the slide rods for the wheels, and then the crosshead, piston, crosshead rails. So here's a part, this is almost exactly from the Virginia drawing, the original Virginia drawing, other than being rescaled. The Virginia drawing was about half the size of this. But for whatever reason, he just decided he didn't like it at all. I guess maybe when he manufactured it, and he remade it here. And when you put the crosshead and guides all together, you get this assembly. I can tell just by looking, this one's going to be all loosey-goosey. But as this moves, so the wheel would go around, that crosshead's going to roll like that. And obviously that's going to drive the cylinder, or the piston into the steam cylinder. And that's a pretty cool part. Sheet 11 is the first of our boiler details. We've got a steam dome cover, steam dome details, and then the layout for the flues and the superheater flue, I guess it is. The exterior, this is the firebox detail. Yeah, not the boiler barrel. And then some interior details. Again, this is kind of easier to see when it's apart. I don't think there's a SolidWorks drawing for sheet 11. Oh, I'm sorry. Well, and look at this while we're here. I forget. So the smokestack, the sand dome, and the steam dome, and the firebox. So the exhaust from the cylinders comes up into this box here. There's a bulkhead. No, there's no bulkhead here. So the exhaust will come up into here. There will be a bulkhead when the boiler's installed, and the exhaust just literally escapes out the front. There's a door on the front to open up so you can get in and do maintenance and clean the face of the flue pipes. The sandbox is interesting. I didn't know anything about it when I started this project. So apparently they used to actually have sand tubes that would come up in front of the drive wheels and drip sand on the track to give it some extra traction as needed. This is a steam dome. We'll talk about that in a few seconds. So basically what happens is the boiler surrounds the superheated gases from the fire. The water flashes the steam. It goes up. It collects in the steam dome. It then goes down into a pipe, which goes into so the pressure is building up in here. Then using the throttle, you can open a valve, sending the steam that was collected in the boiler, now is up in the steam dome, through a pipe, through the other rest of the pipes to the superheater, then down to the pistons. That'll be a little easier to see in a second. Sheet 12 kind of shows us a side view of the same thing, right? So our boiler, our tubes, fire door details. So the fire box sits inside the boiler. There's water on three sides of it, and it gets hot as heck. And then the gases pass something else I never quite understood, that the gases from the fire pass through the tubes uninterrupted and go straight out the smokestack. The difference is there's water here and here. Touching that pipe is what flashes it to steam, rising to the top of the boiler, rising back up to the steam dome here, and then back into our throttle assembly, which will be here in a second. In this case, the superheated gases run through the tube and out the other end, straight out the exhaust. But in this case, this steam pipe comes down, travels back through this pipe, which is a U-bended tube, comes back through a second one, and then back out. So if we backed up a drawing, it goes forward on this tube and comes back on this tube. Or No, that's wrong. It comes out of here. This is the back. Now take it all the way to the forward end. Then it goes into this tube and comes back at us, makes the U bend, and goes back to the front. From the front, it goes down and out to the outlet here. And the same on this side. Goes forward, comes back at us, makes a U, and then goes down to the port side. That's these holes here. You can see the tubes there. So again, the parts in red are, let me jump to sheet 12. Okay, that's sheet 12. 13 is the other details of the smokestack, the sandbox, the throttle details, the throttle lever, the bell. So now we have our boiler assembly. In this case, again, the red parts are the parts I kind of made up because he used copper tube here. I'm just going to use plastic. We can see those flues, the tubes, just letting the superheated gases come forward and aft. Okay. If I change the transparency on this, we can actually see those tubes running forward and back. Right. If I clear this one, sorry, we can see the superheater tube inside of it going back and forward. Right. The firebox, there's those tubes. So it comes down, forward, down the red pipe, this length, wraps around, back up, comes back up, goes down, off to the cylinder. Right. The fire door, I made it flexible. I'm going to have to lock it because I don't want to bother to print it. But the interesting thing here is there's no way to operate the fire door. So right now the valve is full on, and this would be full off. So there's no way to put coal in the boiler. And I thought he just made a huge mistake, but then I realized, well, no, he ran this off of propane. So this would have been closed, and he would have never, ever needed to put material in while the engine was idling. Or when it was, and he also just made this large enough that he could hold it. So, yeah. So he wasn't an idiot. He knew what he was doing. I'm the idiot. So if we transfer this now, so the steam comes in, and you can see we've got a taper here. As this goes, it allows more or less steam into the system, just based on the diameter, how much steam you're letting through, how much pressure you're going to let, to the rest of the system. It's really cool when you just learn how the steam engine is. When you think of when they made them, I don't know when they first came around, what, the late 1700s and the early 1800s. Locomotives were certainly in the 1800s, and it's simple tools, simple designs, no CNCs, just big iron foundries, and they just worked. Yeah, I'm really happy for this project because it's just taught me this whole system, and it's so cool. So sheet 14. Oh, so that's it. So that was the end of this. So sheet 14 is the tender. I haven't modeled it at all. I may or may not. I don't know. Here's the truck frame for the tender. The tender contained the water and the fuel for the locomotive, the water to refill as it steamed off, and then the coal or lumber to burn. There's no labeling on this, but it certainly seems to me that he's a pressure relief valve that he's made, probably for the boiler. I might be wrong. This is the top of the carriage. He made a carriage car. Looks like the bolster for the truck, for the wheels. And then here's the carriage. Again, I don't know that I'll make this ever. I certainly haven't modeled it at this point. The trucks for the carriage. I think, if I remember right, the date on this was a little earlier than the other ones. So this was his original drawings, and then he remade them on the ink and vellum. Here's another early drawing. This is 1982. The other ones were 83. So I think he changed his measurements and dimensions. That's a duplicate of the ones we've already seen. And we're back to the front. So when you, back to the front, good song, Metallica. So when you put it all together, you end up with something that looks like that. Now, the other key thing that we've noticed, there's no cab. He didn't design a cab at all, or he didn't show me the drawings for it. But I was able to take his original Virginia drawings, not the Virginia 2, but the Virginia 1, and kind of figure out, well, it should look something like that. And then the photographs that we do have. Steve had some photographs that he was able to share with me that gave me a little bit of detail of what we're looking at. I renamed it the GJ Horban, and that way my print will be, my files are actually going to be, currently, as you can see, they're called Virginia 2. But when I remake the whole thing, it's actually going to be the GJ Horban because it just flat out should be. So I think that's it. What we end up with, Steve had this drawing for me, or this picture for me, which was really helpful figuring out this valve gear stuff. Because although I can't really see the detail, it gives me the general shapes, and I know that arm's supposed to come up and over. Looks like those all connect together. Here's the frame. Now, I wish I could see what's going on inside the frame, because this link right here, which is not this one, that's the one that was giving me the hardest trouble figuring out where it connects to the bell crank in the middle and this arm out here. But in the end, we got it. This was super, just being able to kind of get the general idea here was super helpful. Here, again, we can see his cab compared to mine gave me the shape, the tender, his carriage that he made. And I'm not going to make tracks around the yard, but Cheryl thinks I should. And then I asked her, well, how am I going to get air pressure to it the whole time it goes around the yard? She says, well, do it the way he did. And I said, you can't light a fire. And there's our pop, Jerry Horban. And so this picture was probably 1984, 1985. And he had it run a track around the yard. And we're not sure who these other two gentlemen are. Probably somebody else from the Miami Live Steam Association. So in this case, he's got a carriage on, but not the caboose. In this case, he's got a caboose on. Oh, actually, I guess it's the same part. It just doesn't have the roof on it. Here we can see it wrapped around the yard that way. Yeah, good stuff. Now, this is a totally different cab. If we look at this one, there's no plank walk running up along the side of the boiler, where in this one, he does. So, again, I'm not share why there's multiple versions. I've chose to go with this one because I like the look of it. And choo-choo, there we go. So the next step, obviously, is to remake the model in Solidworks for 3D printing, and then start printing it. And I'll send videos of those when it's working. Thanks, guys.